Welcome to the final week of ESM 101. Today we're going to talk about scientific evaluation of environmental projects, and many of these are very complex. There's a lot of slides today, and I'm going to be working through really sort of the steps in evaluation, but what I want you to pay attention to is the middle part when we evaluate the assumptions that went into some of these environmental projects. That's really the key for this course, is how do we evaluate those assumptions and scientific models that are being used. So the themes for today are that, as Peter Drucker said, management is doing things right, leadership is doing the right things. This is a big challenge for us because in environmental projects, sometimes they're so large and irreversible that we better be doing the right things, not just dotting our I's and crossing the T's. Okay, and there are multiple definitions of science, and some of those include values. We've talked about those earlier in this class, and we're going to see how those inform our approach to evaluation. And finally, we have these complex and wicked problems that they require management schemes that really do match the complexity of the problem itself at the levels of the landscape and scale and the types of issues that are addressed. So we're going to try to hit those themes today. Just an overview. I'm going to review what scientific adaptive management said and how that leads into evaluation. Again, because most of the problems we're looking at are of interest, are wicked problems, and they're going to require scientific adaptive management. Then I'm going to talk about the multiple types of science, including transdisciplinary science. And then we're going to go through a list of criteria. But again, the main part of today is going to be to work through this example and focus on evaluating the assumptions and the underlying models that we would use to manage those. And finally end up with a little bit on the challenges as we move forward. So scientific adaptive management and evaluation go together. In scientific adaptive management, we have using management perturbations as experiments. The point is to decrease the uncertainty and to provide for a broad stakeholder input. In evaluation, what we're talking about today, it's going to be based on a scientific approach, which means we need to have evidence that can be independently verified. The rigorous methodologies doesn't mean that it's hard and strenuous. It means that it's detailed and disciplined, that the methodology itself helps avoid many of the mistakes. And then finally, we need to see how this evaluation, how these projects create new knowledge, and in particular, how people learn, but also how institutions learn. And finally, we're going to be addressing values, and as we've seen before in the class, the point of this is to make objective statement about values, not to make value statements. So, new modes of science that have been developed in order to deal with the new problems we're facing in environmental science really help us really add to the discussion about what we can do. So these new modes are used in addition to traditional science, not to replace traditional science. And I think this is where the culture wars got off track, is that we're using more tools, not just replacing one tool for another. Now, transdisciplinary science is really when we go beyond academic disciplines. And the graphic over to the right shows the path of transdisciplinary science, where we'll have, in the university, we'll have teaching courses and individual research investigators. Then as the projects get larger, we do research, and we might have collaboration between investigators and centers or institute. And traditional science, such as biochemistry, medical research, this is where it goes into translational. It moves out of the research into medical practice. It gets translated from one form to the other. In environmental science, it's a very different mode. We have this environmental work that the faculty do, environmental research that the students do, and internships and finding new ways to solve problems. This is an extension of the scientific work out into the scholarly community. So it's a very different sort of thing from making new drugs and making new ways to solve problems and translating that into a corporate world for the wider dissemination of that of the benefit, to actually being an extension of what we already do in the environmental science. So the life of environmental scientists is much more about forming collaborations with external organizations than it is finding an opportunity to have the product or process be translated to sort of business community. Another definition of science, that is post-normal science, states how we need to have standards that actually include people's values. What do people value, and that scientific standards should include that. Draw on an extended community, that is experts and people with experience in the community. And finally, that uncertainty is central. So defining what we mean by uncertainty is one of the key pieces of post-normal science. And as opposed to traditional science, where uncertainty is really the lack of knowledge, instead post-normal uncertainty is something that's central to what we have to deal with, and that it's not going to go away even if we do enough research. And another example is mode 2. It's called mode 2, and it says that the future will be uncertain and in ways we can't predict. So again, uncertainty is central to this, but also that we need to allow for surprises. We have to take risks, and that's how we're going to learn. So just designing a project that reduces the risk of something bad happening actually restricts our ability to learn. So we have to tread that tightrope about how much we can risk in order to how much we can learn. So, in summary, just how these new modes of thinking about science might help us with evaluation. One is we're going to have stakeholder input, and that's going to be experience, people that have been around for a long time in that particular habitat or environment, and also expertise, bringing in people that study this maybe on a very practical method. Not just scientists, but people that are actually involved in day-to-day operations. We're going to include values, objective statements about values, and that the projects need to have an intermediate level of control. So instead of just designing a project that's so well, all of the little parts are identified and we just follow that plan, that would be too severe. It would eliminate all risk, all sort of opportunities to learn from those surprises. But on the other hand, if we allow too many opportunities, it's too lax. There's just too many options. We can't formulate the management procedures as actually a viable experiment. We're not going to learn anything from it just because there was too many possibilities. So again, we're in this middle zone of trying to control a project but not eliminate all the risks. The other thing is we're going to have potential solutions that involve multiple sectors. By that I mean business, the public sector, education sector, research sector. All of those are going to be involved, and therefore the evaluation needs to say how well that collaboration worked, not just was it published in a scientific journal. And finally, as we mentioned before, we need a way to describe what we know versus the uncertainty that exists, and in a way that helps us describe how this changes, not that just that there is uncertainty, but we have to know what we don't know. Okay, these are the brief criteria for evaluation. I'm going to go through this pretty quickly. This is not really the the guts of what I want you to get about today, so don't dwell on this too much. Really, the guts is the evaluation of the hypothesis and underlying models. So first, as a criteria for evaluation, we'd start out with a value statement. What is it going to be clear enough for the whole community to understand? Then we'd do some background and introductory information. We need that. We need the narratives, and they have to be broad enough so that people from all different points of view can understand them, and they have to be in a sort of a standard language that everybody uses, not scientific jargon, and not just dumbed down so much that we can't get at specific components. It has to be right in the middle there. And then the other thing is that these scenarios that we describe can't just look like they're make work to say this scenario is way too extreme one way and this scenario is way too extreme the other way, and so, well, we got to change the middle scenario, this sort of Goldilocks set of scenarios where one's too hot, one's too cold. You see that way too often. We need to get away from that. Okay, the statement of the goal should be clear and engage the broad range of stakeholders, even though they might not agree on every particular objective. And the objectives, and again, we're going to get back to this in more detail, we need them to be stated as hypotheses for management, and that is because most of the problems we're dealing with are scientific adaptive management. If we had a very simple project, like getting the lead out of gasoline or something, the objective would be just stated pretty much much more directly. The technical specifications and budget, those are self-explanatory. The new knowledge is this idea of what knowledge was created, how was it used, how were the new areas identified. We need ways to describe that, because when we create new knowledge, we also have to put that in the context of what gaps in our knowledge led to uncertainty, or the so-called ingenuity gap. And then the final two parts are adaptation. Was there evidence that the project, as it went along, adapted to new knowledge or uncertainty? And then did the project itself create the capacity for ongoing management to create that functioning? So the sustainability of this type of approach. So I'm going to go into detail on an example, and this is a hypothetical case study of there's a community, small number of people live in this, and they have some natural resources, including a diverse forest that has some pasture land in it, has a wide range of trees. Then they have a fenced pasture area for livestock. They have an agricultural area for row crops such as corn or wheat, and they have a lake. And the lake is fed by a stream that comes from the forest. So they have this whole set of facilities of assets. The homes are owned by the individuals, but somehow the overall community owns this whole set of natural resources. So this, you could think maybe it's like an island where all of the natural resources are owned by the government and have to be managed. So first, we're just going to go through these steps of evaluation. Like I stated before, the value, the narratives, goals, objectives, assumptions, other details, new knowledge, adaptation, sustainability. Okay, the value statement for this particular example is that they want to manage this set of resources so that it's a benefit to the whole community. And the narratives would come from different information sources and approaches. So first, the approaches. These are things that we talked about in class, such as patterns. Is there seasonal growth? Is there a mosaic in the forest? What other sort of patterns can you see that might be important to understand? The systems, there's the water flow from the forest to the lake, there's irrigation demands, there's the forest growth rate, there's the number of people that live there and the population growth of the community. There's all these sorts of stories that we could tell using a systems approach. The network approach is a little bit more holistic in the way we use it. There might be disturbances in the forest, maintaining a mosaic in the forest, or these intermediate disturbances, and those could be natural or they could be managed by the community, such as cutting down a little piece of the forest and letting it grow back. There's the resilience, which is the ability of this overall system, including the people acting on this landscape, to be able to survive different levels of disturbance. And finally, the connectivity. And in this, we see connectivity between maybe the homes and the lake with sewage, the forest into the lake with runoff, the pasture, maybe some of those livestock are let run in the forest. There's all sorts of connectivity we could imagine here, and this would be useful to describe. And finally, the uncertainty. What's the variation in the weather? What are the unknowns in the growth rate? All of these things looking at what's the uncertainty in this situation would help us understand the overall project. Okay, the narratives continue on that we could get information from other sources: hunters, fishers, farmers, people that are used to extracting things from the land, but also native plant collectors, bird watchers, people that might have flower gardens. Those sorts of people know a lot about the seasonality and the environmental influences that this landscape has been through. Okay, the goals for this community are to have yield from these natural resources and resilience. That is, don't farm it down or don't extract so much that it's weakened. And that they want to have self-sufficiency for the community in terms of getting as much food and materials off of this, not just for recreation. And they also want to have a right livelihood. And this comes in often when we're talking about small communities managing their own resources, which means meaningful and productive work. They're not just going to farm this out to somebody else, but they and their children are going to be working the land and harvesting the wood, tending the livestock, and they want this to be meaningful. Okay, so the objective in this would be to set up a management plan. And for each part, each subpart, that is the forest, the agricultural land, the lake, there'd be a management objective. And then on top of that, there'd be an integrated plan that identifies the connections and the interdependencies. And hopefully that overall plan would look at what are the synergies. So for example, a healthy forest leads to more stream flow into the lake. A well-fertilized garden doesn't have runoff into the lake. Fertilizer doesn't run off into the lake if it's fertilized at the right amount. So these interdependencies. And then also to address the increased risk because of the connectedness. So for example, if there's a forest fire, they're going to have a problem not only with just the forest, but with the lake. And if there's a bad crop yield, they're not going to have just a problem with the crops, but also with their livestock. The livestock's probably eating some of the forage left over. And then finally, what's the return to the community? Are they getting the amount of work, the amount of food that they want out of this set of resources? Okay, now we're going to turn to sort of the largest section in this particular lecture, which is the assumptions and hypotheses. And I said before how we use models to identify these. And what I want to do now is just highlight some of the underlying assumptions from many of the different scientific models that we've seen in this course that could be applied to this community. Okay, first, when we talk about the yield from the forest or from the pasture, any of those, we might be talking about a maximum sustainable yield. That is, letting the population or the amount of grass or trees or livestock grow up to a certain part and then manage that population by harvesting a yield, and the maximum yield is where the population is at its maximum growth rate. Not when it gets all the way up to carrying capacity, because then it's already slowed down to essentially zero growth rate. Well, a couple of risks of this are that even though we're trying to manage that, there could be sort of overshoot and oscillation, as you see in the second picture over, or there could be overshoot and collapse. So allowing something to go too long without being grazed or harvested could actually lead to, really sort of a oscillation, not very bad outcome, or it could make the whole resource collapse. So these are parts of that model we need to consider. Another model we talked about is the forest as a mosaic, that the forest has many different growth, the growth pattern of the forest, many different age classes of trees, and that as some little parts are knocked down, that provides a grassland that recovers, comes back to different sorts of trees. This leads to a biodiversity and a resilience of the forest as a whole. So this forest as a mosaic was another sort of model that we had that related to intermediate disturbances and connectivity. We also talked a lot about using a common resource. I don't have any picture of cattle or whatever out in the field, but here's just a picture of a mama goat and her baby, and as the mama goat has more babies, the herd of goats is going to get bigger and they're going to eat more. Maybe at some point they have so many goats, even just from one farmer, that they strip the field. So it doesn't always have to be that multiple users are in contention. It can be just, not maintaining the current, good grazing practices on the landscape. So we talked quite a bit about overgrazing and overuse of a resource. Another thing we might want to have out of the natural resource in this area would be to maintain biodiversity. And the biodiversity leads to a healthy ecosystem for the trees, pollination for the plants, obviously in the lake, the biodiversity, that's going to be wild fish source, there's biodiversity there. And you can see this biodiversity, we're talking about sort of a network model of that, and we might have to maintain corridors and connectivity. I doubt in the little community we're talking about that we need to have bridges over freeways, but again, just this graphic reminds us that the level at which some communities have to go to maintain connectivity between subparts of the population. So we'd want to consider that as another goal, sort of a sub-goal in order to maintain the resilience of the overall resource. Now, water resources, we talked about this when we were talking about innovative ways to get more water. And on the left is a picture of a watershed showing the total amount of, just sort of the elevation in this case. And the elevation, when you go down in the watershed, down toward the stream, you get more and more water collecting. So to maintain a watershed that can collect water and push it off into that stream, and so healthy, clean water. And one of the ways to do that is to manage where you either log or harvest in the upland area. And the diagram on the right just shows it's from a resiliency study on how indigenous people harvested different parts of the upper watershed at different times, and therefore there was always this sort of mosaic of upland types that maintained the health of the watershed. So again, selecting where you harvest in the forest might also be related to what outcomes you want for the stream. So you could manage, harvest small little places in the forest on sort of a long-term rotation to maintain that health of the forest and the water that's produced. Now, resiliency is something that was one of the goals, wanted high yield but also resiliency. And the definition of resiliency is how far can this system be stretched and yet still maintain the same sort of behavior. And this ball and cup type model shows in A, it's at the base of its resiliency, but if you apply a certain amount of stress, B gets just to the top of that. That's the limit of the resiliency. Any more and it's going to fall over into that basin on the right. And so this is the point. It's not to avoid stress, but to manage the stress on the ecosystem. And this might be, cutting down trees is a stress on the ecosystem, and by managing that, it stays within a resilient basin that has the same characteristics, instead of flipping over to, say, losing so many trees that the soil dries out and that moves from one productive forest to a scrub forest. Okay, a big uncertainty we have in these sorts of natural resources, especially those based on agriculture and, say, tree growth, would be the harvest versus the weather pattern. So if you set a particular harvest rate and the weather was cooperative, you could maintain a high level of harvest. But for the same type of pattern, not the same pattern, but the same probability of extreme events, you see in the pattern on the right that that loss pattern with the same harvest ended up as collapse. And so this is the type of uncertainty. Even if you understand the sort of statistical nature of the weather pattern, you have to be able to adapt to sets of bad luck that end up in a collapse of could end up in a collapse of your resource if you keep harvesting the same way. So you have to be adaptable, and that's understanding these indicators from your harvest. Okay, and the final part is about sustainability, and I've got several panels here on sustainability, and one is that sustainability first is just to keep away from poisoning yourself. Now this sounds pretty obvious, but when you have a small community and you have waste, What are you going to do with it? The resources can be turned into, things that benefit the population, but also resources can accumulate as pollution. And this can happen even in a small community. You can have you can have too much animal waste. You can have too much household waste, and it ends up polluting the lake. So this is like the first line of defense, is you have to maintain a relationship between resources and what happens to those resources so it doesn't accumulate as pollution. Another thing to remember on sustainability is that all things are connected, and this little diagram shows how soil moisture, plant growth, organic content of the soil, and the coverage are all connected. If you interrupt any of those, so for example the plant growth, if you cut down too much, you dry out the soil, the organic content goes away, it won't hold as much moisture, it's going to shift to a much different sort of plant growth if you just disrupt one of those. So these are self-reinforcing, but once they're disrupted, you end up with a big threshold that you have to overcome in order to reestablish a healthy community. So again, sort of the second level of sustainability is remember that everything's connected and a plan for that. And then really sort of the third level of looking at the sustainability would be, what are the people doing in this situation? And back in the systems chapter, we talked about that. We were talking about a model for what happened in Easter Island, Rapa Nui, that the people were cutting down the palms, and then the palms, when the palms went away, then that also interrupted the rats, and the rats were a major source of food for the people. So this sort of interconnectedness is really crucial to study when for ecosystem resources at the system level. And over on the right, we talked about just what's the population size, how does that relate to the wealth. And in this case, we could have economic growth that is representing the growth of the natural resources community has access to. A bigger population decreases that wealth per capita. That might be a trade-off they want to make. They might say, well, we've got plenty of natural resources, we can have a few more people. But if they just let the population increase without being aware of that, they're going to end up with less and less natural resource per person, which would go against their goal of being self-sufficient. Okay, now just back to the list of the evaluation steps. And these are really just sort of to finish off the list. Those other details, the technical specifications, obviously those have to be met, things like meeting water purity standards, having safe practices in the forest, all of those sorts of things. The budget is really, one, is it feasible to take on this project, but there's also the political aspect of maintaining enough budget in order to run this project. And that's a political choice, and it often gets undermined in these sorts of long-term projects. Now, the creation of new knowledge, this is what we want to evaluate. If we were doing a scientific evaluation based on what we've studied in this class, we would really look at the assumptions in the models. That's what we have something to we can really contribute. And then also this creation of new knowledge. When we create these new narratives, combining new and old information, did we really come up with something new, or did we already know that? When we monitor the project, do we just sort of reaffirming what we already know? Are we doing it in a way that we can understand how the system works? And there might be cases where we have to make some deliberate hypothesis testing. Maybe they have to test, should they grow corn or should they grow wheat in the field, and what was better for both the lake and then also maybe the connectedness to the stock that are, the livestock that are growing. And finally, and this is a key piece that is sort of beyond the scope of what we're talking about overall in the class, but we have to remember this, is how did the institutions work? Did they work well? Did they learn? And what was the role of tacit knowledge, that is, how to do things? Often this is underappreciated in the strictly scientific literature. I mean, if people know how to raise livestock and they pass that on to their children, they didn't really do it through scientific writing and documentation. So that part also has to be addressed. And the final two steps here are the adaptation, looking for evidence that the organization, that is in this case the community, use the knowledge they had and change their procedures or even change their objectives. That's the adaptation that's essential if this is going to be a adaptive project. And then finally, the sustainability, based on how it's operating now, just not promises for the future or anything like that, but can you evaluate whether the knowledge is the uncertainty decreasing? Do they know more about how to operate this now than they did before? And then the control, is the governance in the community matched to the complexity of the problems? And then also this sort of threading, walking this tightrope between, is the governance simple enough to actually work but complex enough to be successful? And that's where the governance embedded in community structure is often gets its complexity from the community structure, even though it has very simple rules. And then finally, the values. Are there existing mismatches that need to be resolved, that is between individuals and community? Are there equity issues where somebody's not getting what they really deserve? And then, are the resources seen as being increasingly valuable to the community, or are they being discounted? And those are questions that we can make objective statements about how the values are playing out in the community. Okay, now let's say we did this evaluation and we had a nice functioning community and it was operating now, and we did this evaluation. It would be ongoing. We would say, well, maybe we need more information about particular aspects of running this natural resource rich community. So just to review, the technical science on its own is inadequate. There's an ingenuity gap that relates to all of these types of problems and how we apply the science. These complex and wicked problems are never solved, and they entail substantial uncertainty, and we have to continue addressing these problems. So they're never quite gone away. That's why you need a continually adapting program for evaluation. We're challenged by the general population wants to avoid uncertainty, and yet the new modes of science that we're talking about have uncertainty as a central principle. That's just something that we're going to have to try to work on as scholars and citizens. And in some of these areas, the democratic processes are also stretched to their limits. That's the uncertainty and the complexity of the issue makes it really hard to just have a simple vote on some outcome. Now, there's some new issues related to evaluation. A technical review doesn't tell you if you're doing the right thing. You have to back up, take the larger view, the longer-term view to determine that. And yet, as we say, well, take the longer-term view, sometimes time is running out. If we took the time to do a robust evaluation, everything could have already failed. Maybe this project really needs a kickstart, and to get a healthy forest management program going and a healthy agriculture program going, might have to make some cut some corners in order to get that to happen. And then there's some emerging opportunities that I think are relevant to this course. One is we can create new ways to have social media. So we talked about this being a small town, but what if it was a town of several thousand people didn't see each other all the time? Maybe they needed more connectivity in the community. So there's new ways to get that information out within the community to increase involvement. And one of those ways is by the aggregation of information sources and data collection. So we've seen that before, where air quality, health, and demographics were combined to show that certain areas of the city were unhealthy. We have monitoring archives, new data streams that go out, increased citizen involvement, and this is related to, say, online weather predictions, so that people can look at how, sort of in real time, what's happening what's the impact of their projects. And then finally, another one I mentioned, sort of in the innovation part, is that wrap this into the permit process. That in the permit process, you have to have ongoing monitoring, and you aggregate that, and you're actually getting a permit as part of a community of people working on the problem rather than just as an individual. All right, well, those are some challenges and new opportunities that come out of this evaluation. And again, when you look back at this lecture, you see, well, we really did look a lot in this course on how we might evaluate those underlying models and assumptions that lead to wise use of resources. So I'd like to thank you for a good term. Good luck on the assignments for the rest of the week, and have a good winter break.